In this video, we'll be talking about the mole, and I don't mean your garden variety. We'll be talking about the mole as a unit for counting large numbers of things, anything really. We can count peas in terms of moles, we can count people in terms of moles, and most of the time though, we'll be talking about moles with respect to atoms, molecules, electrons, etc. So we often say that the mole is the chemist's dozen because it works the same way. 1 dozen objects has how many objects? It has 12 objects, as I'm sure you're aware. There are 12 eggs in 1 dozen. The mole, on the other hand, 1 mole of objects is equal to a much larger number, 6.022 times 10 to the 23rd objects. So you'd have to have a whole lot of eggs to have 1 mole of eggs. But because molecules and atoms and electrons, whatever we're counting on the atomic scale, are so small, it's useful to have this quantity at hand to make the numbers more manageable for us. We're going to need to be able to use this mole number of 6.02 times 10 to the 23rd power to convert between moles and number of objects, or the opposite way, from number of objects to moles. And it's going to work the same way as if we're talking about dozens. Let's look at an example that we may have seen before. If there is a bag of Skittles, a 1-pound bag of Skittles that contains 480 Skittles, how many dozen Skittles are in the bag? Well, we know that there are 12 Skittles per 1 dozen Skittles. So our units will cancel and we'll be left with 40 dozen as our answer. Using the mole conversion will work the same way. If we're starting with some number of objects, we can convert to moles by dividing by Avogadro's number, 6.022 times 10 to the 23rd objects in 1 mole. So our units will cancel, we'll be left with moles. The opposite case, where we start with moles and are asked to convert to objects, again, objects being atoms, molecules, photons, whatever we're interested in counting, we would multiply by Avogadro's number, 6.02 times 10 to the 23rd power objects per 1 mole. Let's try an example. Let's say we have a 1-pound bag of Skittles that contains 4.7 times 10 to the 21st molecules of sugar. Okay, how many moles of sugar would this be? Well, we know that for every 1 mole, there would be 6.022 times 10 to the 23rd molecules. So my molecule unit will cancel and I'll be left with moles. And working out the math, we get 7.8 times 10 to the negative 3rd moles of sugar. So a small number of moles, less than 1 because we have less than 1 mole of sugar molecules. Let's look at a different type of problem. Let's consider that we have a car that has 4 tires. If we have 2 moles of cars, how many total tires do I have? So we have one extra step to solve this problem. We have to consider what's called the mole ratio. And that would be how many tires per car. So 1 car has 4 tires. And likewise, 1 mole of cars would have 4 moles of tires. There are 4 times as many tires as there are cars. So when we go to convert moles of cars to number of tires, we would have to use this mole ratio. And we would arrange it such that our mole units canceled. So 1 mole of cars must be in the denominator, 4 moles of tires. So my cars will cancel. I have moles of tires. And to go from moles of tires to number of tires, I know that 1 mole is equal to 6.022 times 10 to the 23rd tires. I will get 48.18 times 10 to the 23rd tires. Let's apply that same process of problem solving to an example using atoms and molecules. So if we have sugar, your typical table sugar is C12H22O11. And I want to know how many atoms, how many total number of atoms are present in 1 mole of sugar. So I'm given that there's 1 mole, and I need to know this ratio again. For every 1 sugar molecule, how many atoms do I have? If we count them, we have 12 carbon atoms plus 22 hydrogen atoms plus 11 oxygen atoms. So I have 45 atoms. So again, for every 1 mole of sugar atoms, 1 mole of sugar molecules rather, I have 45 moles of atoms. So 45 moles of atoms per 1 mole of sugar. So I have 45 moles of atoms, but I'm going to total number of atoms. So there's 6.022 times 10 to the 23rd atoms in 1 mole of atoms. So I have total 2.709 times 10 to the 25th atoms present. I can look at sugar again and do the same thing, accounting for just, say, carbon atoms. If I have 1 mole of sugar, again, how many carbon atoms are present in that mole? Well, I know for every 1 molecule, there are 12 carbon atoms. So, for every 1 mole of sugar, I have 12 moles of carbon atoms. And to get from moles of carbon atoms to number of carbon atoms, I would use Avogadro's number, 6.022 times 10 to the 23rd carbon atoms in 1 mole of carbon atoms. So this calculates to 7.224 times 10 to the 24th carbon atoms. Those are the 2 ways that you can use Avogadro's number to convert from moles to atoms or atoms to moles. We represent Avogadro's number with the letter N sub A, if you ever see that in a notation. So 6.022 times 10 to the 23rd. And the units are whatever we are looking at. Thanks for watching.